Every fall in the Red River Valley, more than 13 million tons of sugar beets come out of the ground. That number set a record in 2024. On a single day, October 6th, growers piled more than 1.2 million tons of beets. Across the whole season, that adds up to something like 15 billion individual beets. And most of it ends up in a 4-pound bag on a store shelf, with no clue what came before it. Here's the part most people never see. The sugar in your kitchen probably didn't come from sugarcane on a tropical island. There's a very good chance it started as a fat white root pulled from cold Minnesota dirt. About 1 out of every 7 pounds of sugar in America comes from one farmer-owned company in this valley. It's a giant hidden system, running non-stop for months, and almost nobody knows it's there. Today, we're stepping inside the massive and modern sugar beet factories of Minnesota to follow one beet from a mile-long outdoor pile to the white crystals in your coffee. And there's a number to keep in mind. These plants run 24 hours a day, 7 days a week, for about 280 days a year. That's a longer run than almost any sugar operation on Earth. How they pull it off, and why the winter itself does half the work, comes later. First, the beet. Let's start where sugar beets grow. The Red River Valley sits on the border between Minnesota and North Dakota. The soil here is dark, deep, and rich. It was left behind by an ancient lake that drained thousands of years ago. Flat land, cool climate, long summer days. For a sugar beet, it's close to perfect. Through 2018, Minnesota was the top sugar beet state in the whole country. More than 415,000 acres planted, nearly 10.5 million tons of beets in a single year, and those numbers have only climbed since. A sugar beet doesn't look like much. It's a pale, cone-shaped root, about the size of a large potato or bigger. Some grow to 2 or 3 pounds. On the outside, it looks like a giant parsnip, but inside, that root is packed with sugar. Around 15 to 18% of its weight is pure sugar. That's the whole reason it exists. The plant makes that sugar all summer long. Its leaves catch sunlight and turn it into sugar, then push it down into the root for storage. By fall, the beet is loaded. That's when the clock starts. The harvest is a race. In the Red River Valley, thousands of growers dig their beets in a short window each fall, usually starting in late September and pushing hard through October. The reason is simple. The beets need to come out before the ground freezes solid. Once winter locks the soil, you can't dig. So for a few weeks, the valley never sleeps. Machines called beet lifters roll through the fields. These are not simple plows. Modern beet lifters are massive, self-propelled machines, often weighing more than 30 tons. They can harvest multiple rows simultaneously, typically 6 to 12 rows in a single pass. As the machine moves, specialized shares or lifter wheels gently pry the beets from the soil. Behind these, cleaning wheels or chains rotate, knocking away the bulk of the dirt clinging to the root. Then, the green leafy tops, which are not used for sugar production, are precisely cut off by a defoliator or scalper. This process is designed to minimize damage to the beetroot itself, as any cut or bruise can lead to sugar loss during storage. Behind these giant lifters, a continuous stream of trucks pulls up alongside. These are not just any farm trucks. They are specialized semi-trailers, often with high sides, designed to handle the sheer volume and weight of the beets. A single truck can hold between 25 to 40 tons of sugar beets, sometimes even more. As the lifter moves, an unloading elevator on the machine continuously transfers the cleaned beets directly into the moving truck. This synchronized dance in the field is a marvel of agricultural engineering, allowing for uninterrupted harvesting and transport. These trucks run day and night. Down every gravel road, headlights move at 3 in the morning. The beets go straight to receiving stations. American Crystal Sugar, the company at the center of all this, takes in beets at more than 38 receiving stations spread across the valley. At a receiving station, every truck gets weighed. This is the first critical step. Large industrial scales record the gross weight of the truck and its load. Then a sample is pulled and tested. This matters more than you'd think. The growers don't just get paid by weight, they get paid by how much sugar is inside their beets. So a machine takes a scoop, often an automated core sampler that extracts a representative cross-section of beets from the truckload. This sample is then rushed to an on-site lab. There, the beets are washed, shredded, and a precise amount of the shredded beet material is processed. Sophisticated instruments like polarimeters measure the sugar content with high accuracy. This process determines the purity and sugar percentage, usually between 15% to 18%. Higher sugar, higher pay. It keeps everyone honest, and it rewards the growers who took the best care of their crop, incentivizing optimal farming practices. Then the truck dumps its load. This happens quickly, often using hydraulic hoists that tilt the entire trailer or through bottom dump mechanisms, and the pile begins to grow. And these piles are the thing you have to see to believe. They are not small mounds. They are walls of beets nearly 3 stories high and up to a quarter-mile long. Picture a hill of white roots stretching the length of 4 football fields, taller than most buildings on Main Street. These are built by specialized piling equipment, giant conveyors that can stack beets to incredible heights and lengths. Seasonal workers weigh, tag, sample, and pour beets around the clock for weeks to build them. Each pile is meticulously constructed, often with a peaked top to shed rain and minimize surface area exposure. Why pile them up at all? Why not just run them straight through the factory? Because no factory on Earth could process 13 million tons of beets in the 6 weeks it takes to harvest them. The beets come out of the ground far faster than any plant could turn them into sugar, so the piles are storage. They hold the crop while the factory works through it slowly, over months. But storing a beet is a problem. A beet is a living root full of sugar and water. Left in a warm pile, it would rot, heat up, and lose its sugar fast. The respiration process within the living root consumes sugar, converting it into carbon dioxide and water, which means a direct loss of the valuable product. In warm climates, you can't store beets for long at all. Even a few days at elevated temperatures can lead to significant sugar degradation. So how does this valley keep 13 million tons of beets fresh from October all the way into spring? The answer is the cold. Minnesota winters get brutal. Temperatures drop well below zero for weeks at a time. And that cold is free refrigeration. The valley uses its own weather as a giant walk-in freezer. Once the piles freeze, the beets go dormant. Their metabolic activity slows dramatically, almost to a standstill. They stop breaking down. They just sit there, cold and stable, waiting their turn. This natural dormancy is what allows for the extended processing campaign, often stretching from October through April. But it's not as simple as letting nature freeze everything and walking away. The company works hard to keep those piles alive. Each pile is a carefully managed ecosystem. Big fans, sometimes hundreds of them, are strategically placed around and within the piles. These fans push cold air up through the beets to keep the temperature even and prevent localized warming. Extensive networks of culverts and vents run through the base of the piles, ensuring uniform air movement and temperature distribution. Crews walk the piles on a schedule, some as often as every 10 days, looking for hotspots where beets might be starting to rot. These hotspots, caused by microbial activity, can quickly spread and compromise an entire section of a pile. They even use infrared cameras flown overhead, often mounted on drones, to spot heat building up deep inside a pile before it spreads. This proactive monitoring is crucial to preserving the sugar content. If a warm spell hits and the piles start to thaw, that's an emergency. Warm beets go bad fast, and their sugar content drops noticeably the longer they sit exposed, so the plant will speed up and process the softest piles first, prioritizing those at highest risk of spoilage. It's a constant balancing act between the weather, the piles, and the factory's processing capacity. Managing this crop is a science all its own, demanding constant vigilance and rapid response. If you're finding it worth your while to see how a frozen root becomes the sugar in your cupboard, make sure to like, subscribe, and hit the bell so you never miss our next exploration into the giant industries behind the products we use every day. Now let's follow one beet inside the factory, because this is where the root becomes sugar. It starts with a flume. Beets are floated out of the pile in a rushing channel of water. These flumes are essentially concrete channels, sometimes several feet deep and wide, that use powerful pumps to create a strong current. The water carries them into the plant and does the first job at the same time. It washes them. Beets come out of the ground caked in dirt, rocks, and bits of leaf. The turbulent action of the water, combined with the beets rubbing against each other, effectively removes the bulk of this debris. Heavier elements like stones and sand sink out through grates at the bottom of the flume, while lighter organic matter like leaves floats off. Clean beets rise to the top and are conveyed onward. Then the beets meet the slicer. Fast-spinning blades cut each beet into thin strips. These slicers are often large rotating drums, fitted with numerous sharp knives. As the beets enter the drum, they are forced against the knives, which precisely cut them into uniform, V-shaped strips, typically about 3 to 5 millimeters thick and a few centimeters long. These strips have a name in the industry. They're called cassettes. They look a bit like shoestring fries, long and narrow. The shape is on purpose. Thin strips have a lot of surface area, and that makes the next step work far better. A larger surface area allows for more efficient extraction of sugar in the subsequent process. That next step is diffusion. The cassettes go into a long tank or tower full of hot water. Modern factories often use a large inclined rotating drum or a vertical tower, known as a diffuser, which can be over 60 feet tall. Here's the simple version of what happens. Sugar wants to move from where there's a lot of it to where there's a little. Inside the cassette, there's a lot of sugar. In the hot water, which is maintained at around 70 to 75 degrees Celsius, there's almost none. So the sugar just leaves the beet and slides into the water. This process is called countercurrent extraction. Fresh, hot water enters one end of the diffuser, moving against the flow of cassettes, which are gradually depleted of sugar as they move towards the exit. It's a lot like steeping a tea bag. You drop the bag in hot water, and the color and flavor pull out into the water on their own. Diffusion does the same thing with sugar. Slowly, patiently, the hot water pulls the sugar out of the strips. This process can take over an hour in a large diffuser. What comes out the other end is a dark, dirty-looking liquid called raw juice. It's full of sugar, but it's also full of other stuff from the beet that has to come out, including proteins, amino acids, and various mineral salts. And what's left of the strips? The cassettes that gave up their sugar? They're not thrown away. We'll come back to them, because nothing here gets wasted. Now the raw juice needs to be cleaned. This is one of the oldest tricks in beet sugar, and it still works. The juice is treated with lime. That's the same lime used to make cement, a white powder made from limestone. Specifically the lime, in the form of calcium hydroxide, is added to the raw juice. This causes many of the non-sugar impurities, which are often acidic or proteinaceous, to precipitate out of the solution. The lime grabs onto the impurities in the juice, all the little bits of protein and pulp and gunk that aren't sugar, forming larger, heavier particles. Then comes carbon dioxide gas, bubbled right through the mix. This step is called carbonation, and it's typically done in large, agitated tanks. The gas reacts with the lime and forms tiny, hard particles of calcium carbonate. Those particles act like magnets for the dirt. As they settle out, they physically entrap and drag the impurities down with them. This process is often repeated in 2 stages with intermediate filtration to ensure maximum purity. What floats up is far cleaner juice. The gunk, now a thick, dark mud, gets filtered off using large industrial filters, often plate and frame presses or vacuum filters. Do this a couple of times, and the juice turns from dark and murky to a clear, pale liquid called thin juice. It's mostly water with sugar dissolved in it, typically about 12 to 15% sugar. Now the plant has clean sugar water, but sugar water isn't sugar. To get crystals, they have to get rid of the water. That's the job of the evaporators. These are huge tanks where the thin juice is heated and boiled. Modern factories use multi-effect evaporators, a series of interconnected vessels where the steam from one vessel's boiling juice is used to heat the next. This clever design significantly reduces energy consumption. As it boils, water leaves as steam, and the juice gets thicker and thicker. Each stage increases the sugar concentration. By the end of the evaporation station, it's a heavy golden syrup, packed with sugar, typically 60 to 70% sugar by weight. This is thick juice. It went from watery to syrupy, and it's getting close now. The last step is crystallization. The thick syrup goes into big vacuum pans. These are large, enclosed vessels where the syrup is boiled under reduced pressure. Boiling under vacuum lets the syrup cook at a lower temperature, around 60 to 80 degrees Celsius, so the sugar doesn't burn or caramelize. As even more water leaves, the syrup gets so full of sugar that it can't hold anymore. It becomes supersaturated, and sugar starts to come out of the liquid as tiny solid crystals. The plant helps this along by adding a small amount of fine sugar dust as seed. These microscopic seed crystals provide a nucleation point for the sugar molecules to attach to and grow. Each speck gives a crystal a place to start growing. Then the crystals build, grain by grain, over several hours, until you have a thick, grainy mixture of sugar crystals sitting in leftover syrup. That mix has a name too. It's called massecuite. This massecuite is a slurry, roughly 50% sugar crystals and 50% syrup. Now they need to split the crystals from the syrup. For that, the plant uses centrifuges. A centrifuge is basically a giant, powerful spinner. The massacwheat goes into a spinning basket with tiny holes in the walls. These centrifuges operate at very high speeds, generating forces thousands of times greater than gravity. As it spins fast, the leftover syrup, known as molasses, gets flung out through the holes. The solid sugar crystals are too big to pass, so they stay behind, pressed against the wall of the basket. What's left in the basket is white sugar. Real, pure, table sugar. It gets rinsed with a fine spray of water to remove any remaining film of molasses, spun dry, and then run through a dryer with warm air until every crystal is loose and dry. From there, it's screened for size, cooled, and sent to storage in massive silos, or straight to packing. Think about that path for a second. It started as a muddy root in a frozen pile in October. Now it's clean white sugar, ready for a bag. Wash, slice, soak, clean, boil, crystallize, spin. That's the whole trip. And the plant does this without stopping, day and night, for the better part of a year. Altogether, the company turns out roughly 3 billion pounds of sugar a season. The biggest of the 5 factories at East Grand Forks has been running since 1926 and remains one of the company's flagship plants to this day. Now let's follow everything that isn't sugar, because that's where this story gets even better. Because here's the truth about a beet. It gives up its sugar, but the plant finds a use for every single part of what's left. This is a real circular system, and nothing here is truly thrown away. Remember those spent cossets? The sliced strips after diffusion pulled the sugar out. They're still full of good fiber. So the plant presses the water out of them using large screw presses, reducing their moisture content significantly. Then they are conveyed to giant rotary dryers, where hot air reduces the moisture further, often down to about 10 to 12%. That dried pulp becomes livestock feed. Cattle love it. It's sold by the ton to farms and feedlots, and it puts weight on animals. This high-fiber, digestible feed is a valuable commodity for the dairy and beef industries, providing a consistent and nutritious supplement. The leftover beet becomes food for cows, generating significant revenue for the sugar company. Then there's the molasses. When the centrifuges spun the syrup off the crystals, that dark leftover syrup still held some sugar the plant couldn't easily crystallize. This is known as final molasses, or beet molasses. It doesn't get dumped. It's a rich source of fermentable sugars and other compounds. It gets sold as animal feed too, particularly for cattle and other ruminants, where it serves as an energy additive and a binder for other feeds. Or, it's sent off to be distilled, where it can become alcohol, such as ethanol, or used in the production of yeast, citric acid, and other biochemicals. Some of the sugar in that molasses is even pulled out again in extra steps, using processes like chromatographic separation, so almost none goes to waste. Even the lime gets a second life. The lime and mud left from cleaning the juice, which is primarily calcium carbonate, is a nutrient-rich byproduct. This spent lime can be spread back on fields to sweeten sour soil, the same soil that grows the next crop of beets. It acts as an agricultural liming agent, raising the soil pH, improving nutrient availability, and enhancing soil structure. This completes a loop, returning valuable minerals to the land. And here's a use that surprises people. Beet juice disses roads. In winter, road crews mix beet juice byproducts into their salt and brine solutions. These specific byproducts, which contain natural sugars, lower the freezing point of water more effectively than salt alone. The sticky sugary liquid helps the salt cling to the road, reducing bounce and runoff, and extends its de-icing effectiveness, especially at colder temperatures. It's also less corrosive than pure salt brine, making it better for infrastructure and the environment. The same crop that becomes your sugar helps keep highways clear in a snowstorm. Add it all up and you see the shape of the thing. A beet comes in, out the other end come white sugar, animal feed, molasses, soil treatment, and road deser. The root is used down to almost nothing. This integrated system maximizes value from every part of the crop, embodying a true circular economy in industrial agriculture. Now that you know how the sugar gets made, here's the question. Where did all this come from? How did anybody figure out you could squeeze sugar out of a root growing in a cold northern field? The story begins in Europe, more than 250 years ago. In the mid-1740s, a German chemist named Andreas Marggraf showed that the sugar in beets was the same sugar found in sugarcane. He successfully extracted sugar crystals from beet roots in his laboratory. For a long time, that was just a lab curiosity. But by 1802, the first commercial beet sugar factory opened in Silesia, a region now part of Poland. The idea spread across Europe, particularly during the Napoleonic Wars, when a British blockade cut off cane sugar supplies. Suddenly, countries that could never grow tropical cane could make their own sugar from a plant that grew just fine in a cold climate, providing a vital strategic resource. The idea crossed the ocean to America, though it didn't take root easily. Early beet sugar ventures in the United States folded one after another, undercut by cheaper cane sugar and factories that couldn't turn a profit. By 1898, a sugar beet factory finally went up in St. Louis Park, Minnesota. It burned to the ground in 1905. Rather than give up, the operators rebuilt it 30 miles away in Chaska, betting the state's cold climate was worth the trouble. That bet was the first real foothold beet sugar had in Minnesota. Around the same time, a businessman named Henry T. Oxnard pulled several beet sugar factories together across the western United States. In 1899, he formed the American Beet Sugar Company, consolidating operations and bringing a more industrial approach to the burgeoning industry. That company is the direct ancestor of the one running the valley today. But the Red River Valley wasn't part of the story yet. That started with one farmer taking a gamble. In 1918, a Crookston grower named Carl Wigand planted his first beet crop and shipped the whole harvest 250 miles south to Chaska for processing, simply to prove the valley's soil could grow beets worth the trip. It worked, and it worked well. The results were good enough that the company sent a chemist, Henry Zitkowski, north in the mid-1920s to scout the valley's soil and climate for himself. What he found convinced the company to build its own factory on the spot, instead of shipping beets hundreds of miles south. That factory opened in East Grand Forks in 1926, and the beet had finally found its home in the black soil of the Red River Valley. More factories followed as demand grew. Moorhead in 1948, Crookston in 1954, and Drayton, just across the border in North Dakota, in 1965. 4 plants, all within a short drive of each other, all fed by the same valley. Then came the turning point that made this company different from almost every other. By the early 1970s, the growers were tired of being at the mercy of a company they didn't control. They grew the beets, took the weather risk, did the hard work, but the profits went elsewhere. A grower association leader named Aldrich Bloomquist floated an idea that sounded almost absurd at the time. What if the farmers just bought the company themselves? Thousands of small growers buying an entire sugar company outright. It sounded like a stretch, but they voted on it, and more than 70% said yes. In February 1973, the Red River Valley growers finalized the purchase of American Crystal Sugar for $86 million, financed largely through their own equity stakes and bank loans. Overnight, the people planting the beets became the people who owned the plants processing them. That's what makes this company what it is today. It's owned by roughly 2,500 shareholders, and those shareholders are the growers. When the company does well, the farmers do well, as profits are returned to them in the form of dividends and higher beet payments. This cooperative structure aligns incentives, fostering a shared commitment to efficiency and quality throughout the entire supply chain, from field to factory. The cooperative kept growing. In 1975, it added a 5th factory in Hillsborough, North Dakota. In 1977, it opened a research center near the Moorhead plant to breed better beets, developing varieties with higher sugar content and disease resistance, and to improve every step of the processing. And in 1993, American Crystal joined with 2 other groups, the Mindac Farmers Cooperative and the Southern Minnesota Beet Sugar Cooperative, to form United Sugars Corporation. Those 3 co-ops share one marketing arm to sell their sugar across the country. So while American Crystal is the giant, it isn't alone. Southern Minnesota and Mindac run their own beet factories too, and together, this cluster of farmer-owned co-ops makes Minnesota and North Dakota the beet sugar center of America, collectively producing over half of the nation's beet sugar. 50 years after a group of farmers scraped together $86 million to buy their own company, that same cooperative makes about 15% of all the sugar in America. So think about the next time you tear open a sugar packet or scoop from a bag. That white sugar came from a root pulled out of frozen ground in the Red River Valley. It sat in a pile 3 stories high and a quarter-mile long, kept fresh by the Minnesota cold. Trucks moved it at 3 in the morning. A factory washed it, sliced it, soaked it, boiled it, and spun it for months without stopping. And every part that wasn't sugar went to feed cattle, treat soil, or melt ice off a highway. Most shoppers only see the clean 4-pound bag. They never see the 13 million-ton piles, the trucks running through the night, or the plant that runs non-stop from fall until the last beet is gone, usually around the 1st of April. It is farming. It is logistics. It is manufacturing. And it's one of the largest hidden food systems in the country, hiding in plain sight in a cold, flat valley most people drive right past. From carefully prepared fields to supermarket shelves and industrial processing plants, America's sugar beet industry is one of the most efficient agricultural production chains in modern farming. If you enjoyed this deep dive into how a root becomes the sugar in your cupboard, make sure to like, subscribe, and hit the bell. That way, you never miss our next exploration into the giant industries behind the products we use every day.